Hey guys. So I did object-oriented programming last year and I found it quite a difficult subject, and I thought I would make a video where I show you some of the main concepts in object-oriented programming. These are polymorphism, inheritance, and abstract classes. And this is in C++, and it's going to include classes. So I'll be showing you this through a project that you could do using C++. I made a chess game. I'll show you it running right now. And I'm not going to show you all the code. I'm going to show you some modified code because obviously I don't want anyone to plagiarize what I've done. But I would like to show you what you can do with these tools, and I hope that maybe seeing these tools being used will make the subject a lot easier for you than it was for me, because I found that often I wasn't sure how to utilize different tools, and potentially I found that I needed to use online resources to help. So I thought I'd provide you with this resource to help you. So this is the game. It's chess. So it takes a little while because you're doing this in C++. And you've got your different positions. You got your black pieces, so it's castle, horse, bishop, queen. You got your empty pieces, and you got your white pieces. Now this is just how I've chosen to space it out. You can probably do a lot neater than this. Probably think of a really pretty way to do it. And it just asks you to enter the piece you want to move. Now it's white's turn. Let's say if I tried to move black, this wouldn't work. Let's say second row, first column, and let's say we want to move it to third row, first column, wrong color. But let's say we want to move white piece, so that's a white in 7-1, and we want to move this to 6-1. It is a legal move, and it's moved. And it's more complicated than this, but I don't want to show you, spend forever showing you it. You get the point. You can make awesome things with this. I'm just going to show you the code. So this here is a document that I prepared earlier. Like I said, I didn't want you guys to plagiarize. Let's say you wanted to make a chess game. How could you do this? Well, you were going to have your main file, and obviously you're going to initialize everything. So I haven't written all the code. This is all paraphrased. The important thing is you want to initialize an abstract class. The reason you want an abstract class is an abstract class can take the form of any other classes. So an abstract class can't actually exist by itself. That's why we're initializing an array of pointers to abstract classes. And then in these pointers will point to where an abstract class can be stored. And then we're going to create pieces like castle, horse, empty, queen, and that pointer to an abstract class can then be filled with a castle or a horse, which isn't abstract, but it will be a child of the abstract class. And we're going to look at that abstract class and how you create it a bit later. You're going to want to fill this array of pointers to abstract classes with your child classes of the abstract array. That's your castle, horse, bishop. Now you might be wondering why there's a B, why there's a 1 here. I'll show you that later. That is how black is black, B is black, and 1 is white. It was easier to do it this way. But you're going to want to set the turn color. You're going to need some logic for swapping between white, black, and you're going to want to add a condition to end the game. So check, do you want to stop playing? You don't need that, but you definitely want something that's checking whether it's white or black. And then you need to ask for the input. So let's say, hey, what piece do you want to move? Input their location, and then input where you want to move it. Here, this is just some code to show it. So I've taken the input and I've subtracted 1. Now this is because I want the user to be able to say, I want to move the piece in 1-1, and that piece in 1-1 to be this piece right here. But in C++, that is actually 0-0. So that's why I've just automated that with having this -1, -1. Now we need to check whether it's white. I'll show you that function later. And we want to check whether it's valid. We needed 2 get that of pointers to abstract pieces that we then filled and populated with the horses, castles, empties, all of those, all the actual pieces. And we need to plug that into some class that we're going to call the game board. So we're going to initiate a game board. We would have done that up the very top up here. We would have initiated a game board. And we're going to create an object of that game board called chess game. We're going to have a function in game board, which we'll show you later, called setup. And we chuck this class into setup. That stores this class in the game board class, the chess game object. And it will allow us to then print it and edit it using the game board functions through the chess game object. We'll get to that a bit later. Checking if it's white, that's another one of the functions associated with the game board class using the chess game object. And we've also got a test function. Now this test function is another game board function, and this is going to test whether the move is valid. So we're going to get to these later. So we need to check this, look at the test and look at the move piece. These are game board functions. All right, this is just a little aside here before we move on to the game board. When you're wanting to say, oh, this is white, this is black, you might want to use enums. So this enum class, basically I'm saying, okay, we've got white pawn, white king, white castle. These are different types. And then we can set these types. So let's say you can see queen. Queen is of type white queen, and you just say type ... white queen. All right, because if we look here, we've called the class type of piece. You can do type of piece ... white king. And that is going to help you with those black and whites. Maybe that's how you do your black and white check. You just check, hey, it's white term. Is it one of these? And you can literally just say, is it white pawn or white king or white castle, and just have it check whether it's one of those. That's pretty easy. Now, here's the game board. So this is the header file. So they generally want you split it up into a header and a CPP. You can put everything in header, but generally during object-oriented programming, they're going to want you to split them up. So I'll just have the class definition in the header and everything else in the CPP. We've got our move, and the move's going to take in the rows you want to go to and the previous rows where they were before. It's also going to take in a empty piece, and it's going to take in a game board object, and this function of game board takes in a game board, which you can do. The test has basically the same input. But how does the test work? Well, the test is basically simply going to check, is it on the board? So have you asked to move to a place that's on the board, and are you asking to move from a place that's on the board? Then, are you choosing to move a piece that is not empty? So what it's doing is it's checking the piece is not empty, because you can't move an empty piece. We also want to check that you are not taking a piece on the same team. Now, move piece is quite complicated. Move piece needs to check whether the move is legal for every single piece. This is the check that checks whether the move is legal. This is probably the most important piece of code here. So you're saying, hey, the piece that I want to swap, I want to check that it is a legal move for that piece to move where I'm taking it. And now this is going to be different for every single piece. So this is why we needed an abstract class, so that you can have for castle, for bishop, for queen, you want it to be different. So this legal move piece, this is where it all changes. This is the most important thing, because for queen, this is going to be different than for castle. If it is all legal and everything's all good, then you just swap the pieces around. So that's pretty simple. Oh yeah, there's just your function to print. Now, yeah, abstract. How do you do an abstract? The definition of an abstract class is just a class that has a virtual function that cannot be initiated. So this equals 0, you cannot initiate an abstract class. And here, this queen, this is one other thing, castle, queen, whatever, they are childs of the abstract class. Now, what have we said? We've said if there's an integer, it'll be a white queen, and if there's a character, then it'll be a black queen. That's why we had the B's and the 1s. Now, legal move. This is the most important thing. So what legal move is going to do, oh yeah, and we're just saying the name. If it's a white queen, then it will be white queen. If it is not a white queen, it'll be black queen. This is where it's at. You need to create logic for your queen to check that it is legal. You're checking, hey, if it's vertical, you need to check every piece it's moving to. You need to check it's not trying to move through a piece, and you need to check that where it ends up is legal. You need to check it doesn't move off the map. You need to check that it doesn't move and hit one of its own teammates. But it can move and hit an enemy, but it cannot move and jump over an enemy. So you need to check that each pelt it is jumping over is empty. So you need to have the vertical logic, you need to have the horizontal logic, and you need to have the diagonal logic. Every diagonal movement is just one to the right and one up, or one to the right and one left. But you need to have every possible movement checking, and that is where the bulk of your coding is going to be. Or maybe you want to test it. So what you can do is you can create a test file, just a text file, and just put some inputs. So type 3, type this, and you just put them in a text file, and that's the input. And then what you can do is you can create a make file. So let's say you can say, all right, we're going to create, we're going to run the program, compile all this. When you compile this, what you'll get, hold on, there's a bit of a mistake here. You say, like, let's say run all tests, whatever, and then it's going to create something. So this is the file that you run. In this case, it's all tests, but in the case before, it's program. So basically you say, hey, create program. This is your executable. So you have your executable and you're saying, okay, into my program, I want to input my test case. Now let's say it's in a folder. In this case, it's in inputs folder. So you just write, okay, test is in inputs folder, and then if it was in the same directory as program, then you just write tests. But from the directory of program, you need to then open up inputs. So it's saying, hey, get the tests file and plug all of these values into the program. So when this program runs, it just feeds it those values automatically. And then say, oh, hey, can you output it onto a text file in outputs? And then it'll just create a text file that will show you the output of your tests. It'll just put that on a text file, like just as if that's copied and pasted onto a text file. All right, I hope that was helpful. I know it was a bit fast. You might be wanting to like pause and, you know, just have a look at any of the code, any of the logic for different sections. Please comment, give me any questions. But basically, look, enum classes are going to help you. And another thing where I got stuck that was really important and ended up being super important is just this logic of having a pointer to an abstract class, creating an array of that and populating that with these childs of the class. I think this, writing it like this, I want you to basically like, just write it like this, because the best way to do it, if you don't write it correctly, it won't work. And you might think in your brain, oh, there's other ways that I could write this. Surely I don't need to write like this. There are other ways you can write this, but if you don't write it correctly, it won't work. So this is one surefire way to do it, where you have your array, you populate them, and this is where you could potentially become stuck. So you just want to make sure that you're populating an array of pointers to abstract class with the children of this class like this. This line here just helps with testing. You don't need it. Basically, if one of these failed, you would get an error saying pointer to null pointer. You know, oh, okay, I haven't initialized one of these. So I would probably delete this. You know, I'd get rid of it when I'm done. Well, thank you for watching. I hope I've helped. And please just send me some questions. Object-oriented programming is a very hard course, especially if it isn't being explained to you well, it's extremely hard. And I'm not a professional teacher. I'm not really good at this, but I just thought I'd offer this as somebody who's just done the course and found that some of these concepts really complicated. Cheers.